Good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for this lunchtime session in the Australian time zone. For those of you who don't know me, my name is Warwick Rudd, and I'm your host for this virtual session today. Following on from our successful session in 2015, 2016 kicks off with one of the world's leading experts around clustering, Allan Hirt from SQLHA. Now, I'll hand over to Allan shortly, but first a big thank you and call out to our sponsors, SQL Sentry, who assist not just with this session, but other virtual chapter sessions as well. So before I hand over to Allan, just a couple of little housekeeping. So I wanted to let you know, if you don't know already, we've got some upcoming SQL Saturday events both here in Australia and in New Zealand. So in February, we've got Melbourne and Sydney, and then we've got Brisbane later in May, with Christchurch over in New Zealand on April 16. All of these are open for registrations at the moment, and if you haven't registered, I suggest you register now, and you'll have the opportunity to hear from some great local, interstate, and international speakers at all of these events. Now, following on from this session, next month, we've got a session on SQL Server encryption by Ben Miller. So that registration is open now, so make sure that you register for that session, and I look forward to seeing you next month. So without any further ado, I'll hand over to Allan to take us through today's session. Now, change presenter. Okay.
All right. Well, thank you. Let me switch over here. Can you see my PowerPoint there?
Yes, we can.
Okay, let me minimize the this screen over here. Okay. All right. Well, good afternoon, everyone. It's evening my time. My name is Allan Hirt, and for the next hour, I'm going to talk to you about some of the top things, or basically a top 10 list of what you should and shouldn't do for clusters when it comes to SQL Server. Now, just a little bit about my background. I've been working with SQL Server since about 1992. I interned at Sybase, and that's why I sort of started down this road. I've been working with clustering since I joined Microsoft back in roughly 2000. I'm independent now. I was at Microsoft for a little while. I did the SQL Server 2000 white paper. I've done a bunch of books. I'm actually, we're sort of in transition with names. But for the past 6 or so years, I've been a Microsoft Cluster MVP, although everyone thinks I've been a SQL Server MVP. We were just recently renamed to Cloud and Data Center Platform MVPs, but our subsection is High Availability. So I do consulting, I also do training, and obviously a bunch of education like this. And to that point, the only shameless self-plug in here, I'm actually coming down to Australia next month. So if this subject interests you, I'm going to be doing 2 different 4-day Mission Critical SQL Server classes where we're going to talk much more in depth about clusters and availability and disaster recovery. And there's hands-on labs. So you can go to that link there and sign up for either Melbourne or Canberra. Okay, so let's get into the meat of the talk. So the first thing that you should do when it comes to clusters is really understand what it is you're implementing and the stack that it's built on. One of the common mistakes I see with a lot of the customers we worked with over the years, or when I get questions from folks, is sort of a fundamental lack of understanding of what it is they're implementing. Because I've heard quite a lot of times, for example, we have a vendor who told us we need to implement a cluster. We've never done clustering, so we did it and things broke. Well, the reality is that clustering, although it's gotten much easier and much better since I started working with it, has changed, you know, some for the good, some for the worse. But it's still a tightly coupled solution. So you need to know Windows and a bunch of other stuff. It's not just SQL Server. You don't just run a wizard and get a clustered instance of SQL. There's a lot of work that happens well before you can run that wizard to create that clustered instance of SQL or to create an availability group. One of the things that you should hopefully be able to articulate being SQL Server DBAs is the difference between a clustered instance or an FCI, an availability group, which is an AG, or the actual Windows cluster itself. And we're going to talk more about terminology a little bit later in this talk. You should also sort of at a basic level understand how they work, because when you're articulating what's going to be your high availability or disaster recovery solution to your management, to the app owners, as you're trying to say how reliable you are, you need to give them peace of mind. But the other part about that too is it may not be what you think it is. For example, when you do a failover for a clustered instance, it's a stop and a start of SQL Server. Let's actually have a look at that. So if let me go to Hyper-V Manager and go to my FCI here. Let me make this full screen. So I've got a Windows Server Failover Cluster. In this case, it's sony.sqlha.com. And I've got an FCI here. So let me connect to that. So as we're connecting, you'll notice when I connect, I don't connect to the name of the Windows Failover Cluster. So there's a lot of planning that goes into names, things like IP addresses. We'll talk a little bit about that later in this talk, but not a lot. This is something I do a lot with customers because this is part of that fundamental understanding. So I'm connected to my clustered instance of SQL, but now let's say I had a failover, and I'm just going to do this manually. But it's basically simulating a failover. You'll see that things are going offline. And right now, if I try to connect here, see here, select star, because it's already back online. So let's do it in between. So let me just do the failover real quick because I didn't have the query window open. So wait till SQL Server goes offline. But you see it's going through a stop. What that means is that it's going through the full recovery process. So your applications will absolutely notice. See, oh, here we go. It's offline. Basically saying, hey, I can't connect to SQL Server. That's what we would expect to see. But that's what your applications will also experience here as well. So let me zoom in on this a little bit just so you see, transport level error has occurred. That's because it was failing over at the time. And that's, again, a problem. But we'll see when it comes back online, I will be able to reconnect. And your application owners hearing that you have a cluster on the back end is automatically going to assume that, hey, it's going to automatically reconnect and do wonderful things for me. It's not. Now here, obviously, there's no system called sysaval AVA, but it didn't give me the transport error, it just reconnected. So now, for example, I can go create a database. So we'll call this VC test. There we go. So that's one of the fundamental things that people don't understand when you get, for example, a clustered instance of SQL Server. And that's something that you need to absolutely understand. And part of this, too, is also making sure that you're implementing the right solution. Don't implement technology for technology's sake. Implementing just because a feature is cool or seems neat tends to lead to problems down the road. And I can tell you most of the failed implementations I've seen have been because of reasons like this. And speaking of the stack, this is how you need to think about it. So there's some sort of hardware underneath. You have your OS, which is obviously going to be Windows. Then you have the Windows cluster. Then you have, say, an AG or an FCI on top of that. Now, if you're using virtualization, there will be another layer sort of in between the hardware and that Windows operating system, and that would be the hypervisor. And that would be another layer you need to take into account in this entire picture. But this is why, especially when you're troubleshooting, you need to think of it in this way. It's a stack. Another one that I find sometimes trips people up is licensing. And the best advice I can tell you is right there at the bottom of the slide. Always talk to a Microsoft licensing rep. I've been doing this for a long time. I'm just a consultant. I'm not Microsoft. At the end of the day, Microsoft owns your fate. If they say you had to pay something, you do. Use the link there, which has a link to the Microsoft licensing guide. That'll at least give you an idea of what to expect. Now, for example, if you're going to have, let's say, a 3-node availability group, and you want to use one of those nodes as a readable replica, meaning you can use it for things like reporting or read-only queries. That means 2 of those nodes will have live use of SQL Server. So at a minimum, you will have 2 of 3 of those that need to be licensed. So it obviously affects your cost the more things like that you do. So you need to make sure that your solutions are not only affordable, but manageable. And affordability is something that you may or may not control. You may not control the budget. So you need to make sure that if your management wants to do a 3 or 4 node with 2, 3, 4, whatever, readable replicas, they understand the cost of that. Because you don't want surprises. Now, some questions that come up, for example, do I need Enterprise Edition for availability groups? Until SQL 2016, yes. SQL Server 2016 introduces what they're now calling basic availability groups, although the name could potentially change. But bottom line, it replicates a database mirroring scenario of basically a 1-to-1 ratio. And if you're doing clustered instances of SQL, you don't need Enterprise Edition. If you just want to do a 2-node cluster for an FCI, then you can use standard or BI editions, but realize that obviously you're not going to get any of the engine enhancements of Enterprise Edition, but you can still get the high availability of the FCI. Here's another problem that I see quite often at a lot of my customers. When we go into doing a clustered configuration of SQL Server, and I'm sure this is the case in many of your environments, the roles are very segmented. So you have your OS folks, you have your networking folks, you have your storage folks, you have security, you've got DBAs, maybe you have dev DBAs versus production DBAs, however that shakes out. Here's the problem. With clustering, as you saw earlier, it's a stack, and it's a very tightly coupled stack. So if you don't work out ahead of time who's responsible for what, this becomes problematic. And what I've found is that at some point, the other admins besides the DBAs basically say, you know what, DBAs, clustering and it's SQL, and we don't really want to deal with it. All this is now your problem. So what happens is, where you've relied on other folks to do some of these Windows functions or maybe even things in the cluster, now you're responsible for it. I've seen that quite a bit. But if you're able to work out where, okay, we'll handle this bit of administration, you handle this bit of administration, fine. Even if you have the scenario I talked about a minute ago where basically they wash their hands of it, but say that one of those groups is still responsible for patching SQL Server, you need to have great communication, because patching the wrong number of servers and rebooting them in a cluster could cause everything to go down. So these are very poignant conversations that you need to have. Anybody who mentions the word SQL and cluster, if this is not already worked out in your environment. This sort of goes to the number 10, but I want to be very specific on this one. With clustering, there are technical pieces that are shared, but there are other things that are very separate. So the only thing that's the common link between anything clustered is that you have an underlying Windows Server Failover Cluster. And then on top of that, whether you're building AGs or you're building FCIs, everything gets its own set of resources. Now, what do I mean by that? Let's have a look. So if we go back to this clustered instance of SQL, actually, let me show you another example that might be a little more relevant. Here I have do view full screen mode. Sorry, it's not bigger. This is Windows Server 2008, so it doesn't scale very well. We'll zoom it for you, will hopefully help. I've got a Windows Server Failover Cluster named Sticks. I've got an FCI named Grand Illusion, but I've also got two availability groups. Now, each of these, as you notice, this is my FCI. Here's my first availability group. Here's my second availability group. Each of these things gets its own role. Well, in this case, it's labeled Services and Applications in Windows Server 2012. And later, it's labeled a role. But underneath the covers, this is a concept known as resource groups. And you couldn't have just say my clustered SQL stuff as a thing here and have both your AGs and your clustered instance of SQL Server. So that means, for example, every time you create a clustered instance of SQL, you will need to give it its own IP or potentially multiple IP addresses if you're going multi-subnet. If you're doing FCIs and you're using traditional disks, everything gets its own disk resources. You know, each AG gets its own AG resource. The listener associated with an AG gets its own name and IP address. You've got to plan for all of this stuff. You know, because what's going to happen, and I've seen this quite a bit, is your storage folks are going to say, you're going to go to your storage folks and say, all right, we want to implement a clustered instance of SQL Server. I need some disk. They give you a couple of disks, they present them up, and then 2 months later you go, hey, we've got another clustered instance of SQL Server to deploy. And they go, but we've already given you resources. And you go, but this is something new. They're like, but it's clustered, you should be able to share that. You can't. It's not the way it works. So again, it's partially what I talked about earlier of understanding how this works, but also now being able to then take that to the implementation level and understand what is shared and what isn't shared. Now, when you're patching SQL Server, for example, there are some shared DLLs. So if we now go and look at, I'll use the one with the bigger fonts, Windows System 32, so for example here, sqagtres.dll. This is the clustered DLL, or the DLL underneath the covers that the clustered SQL Server agent for my FCI here is using. If I had another FCI, it would still use that same DLL. So if I'm patching my servers, that's a shared resource and could cause me to need a reboot if that DLL gets replaced. So it's more than just what is shared and what isn't shared. It's also what happens in the case of patching. Another common misconception I see here is that people hear the word cluster and they think the word load balancing. FCIs are purely an availability solution, only owned and run on a single node at a time. With AGs in SQL 2016, if you're doing read-only queries, there's the new round-robin functionality. so that it'll essentially load balance your read-only connections. But outside of that, AGs are not load balanced either. So you're going to have to educate a lot of folks on how this stuff works, or they're going to have maybe some conceptual and other problems because they assumed it worked a certain way. One of the things I spend the most time doing with a lot of my customers is planning. And let me tell you a little story. So years ago, when clustering was much more difficult, a customer of mine was implementing a third-party software that supported clustering the instance of SQL on an older version of Windows and SQL Server. And we spent the better part of 3 months in detail talking about how storage would look, because they had some misconceptions there, ran IP addresses, all that good stuff. Well, when it came down to it, the day we went to go build the Windows cluster and then install SQL in it, the process took less than a day. So when we were done and everything was tested, they came back, and they were happy, but they said, we just have a question for you. We just spent, quarter of a year planning this thing, going back and forth, and it took less than a day. What gives? And the reality is, if you plan it and get everything right, things should just work, barring any things like hardware or other issues that may be happening in your environment. But things should just work because you mitigated risk, you understand what things should look like. But if you do what some of my customers do, is that they will call me and say, hey, can you help us implement a cluster? And I'll want to do the planning, like, no, we've got to get this up in 2 weeks. You hit, say, a certain part of the planning or the installation, and it doesn't work, and like, well, and I'll tell them what the problem is, like, oh, that person's out, they won't be in for another week, so we're just going to have to put this off. So something that should have taken much less than a day now takes a month to get done because you didn't plan things properly. So you have to think about it. And now we get into the abstractions of are you doing this on physical hardware? Are you doing it in virtualization? Are you doing it in the public cloud on Amazon or Microsoft Azure or Azure, depending how you like to pronounce it? So, and each of those has different parameters now of how you would get all this stuff done, be it FCIs or AGs. So I have some links later for virtualization, both from a Microsoft and a VMware standpoint in the links section that you can use here, but just understand that it's not all the same, and if you're doing virtualization, in-guest is always going to be the same. And by and large, that's also true in the public cloud. If you're doing in-guest for FCI or for AG, it's all the same. It's the wrapper around it. It's the public cloud layer. It's a virtualization layer that you have to think about. And if you're doing virtualization, meaning Hyper-V, VMware, Zen, the VMs need to have anti-affinity set. And quite simply put, anti-affinity means that the nodes or the VMs can't live on the same hypervisor host. So if you're actually using an FCI, a virtualized FCI or a virtualized AG under VMware or Hyper-V or Zen, it makes sure that you don't have a single point of failure in your hypervisor. This is one that came up actually today on a mailing list I'm involved with. So I've seen more problems, especially in the past year or two of customers, where they have flaky networks, but they want to go do clustering. Here's the problem with this. All cluster configurations, be they for FCIs or for AGs, require that the Windows cluster itself needs to be able to talk to each other. So if the nodes can't talk and the nodes can't communicate, the cluster essentially goes down. So if you have a less than optimal network that has quite a few network blips or a lot of unreliability, doing FCIs and AGs is going to be a bad fit in your environment. No amount of NIC teaming or faster bandwidth is going to help you if the actual underlying architecture is unreliable. You need to make sure that, for example, I've seen things over the years where people have implemented, say, a clustered instance of SQL, a simple 2-node configuration, but the NICs from those 2 server nodes are plugged into the same switch. And then for some reason the switch goes down, which then brings down the cluster. So you guys as DBAs need to ask the question of those racking and stacking if you're doing physical implementations. You know, how is the networking set up behind the scenes? Because they're going to look at you and blame you and say, hey, you put this cluster in, SQL sucks. That's not the case. The reality is that the underlying hardware, which you have no control over, was configured wrong and not proper for high availability. You know, you're going to have to talk to your networking folks and understand things, your subnets, how that's all done. You're going to have to request IPs. It goes back to the resources comment I was saying earlier. I guarantee you, and I make this joke, but it's always kind of true, in almost every company there is somebody in a cube or in a corner or in an office that has a master spreadsheet of every static IP address assigned to a device, to a server, what have you. And every time you want to go deploy an FCI or every time you want to go implement a listener for an availability group, you're going to need an IP address. And this is one reason, for example, why implementing AGs with a listener can be difficult in some environments, because if you want to then go use AGs everywhere and have 1,000 AGs, that's potentially 1,000 IP addresses you'll need in your environment if you're going to use a listener. Can you do that? You really need to think these things through. This is another huge topic which we'll spend a little time on, but I've done, you know, hour and a half talks on this. I did a spotlight session at Past Summit that you can look up from a couple of years ago. I spent quite a bit of time in my class on this, and it's a very commonly misconfigured thing in every cluster, and that is quorum. So what exactly is quorum? Quorum is a mechanism at the Windows layer that basically helps the Windows Failover Cluster remain up and running. If you have enough what we call votes, and every node gets a vote, and certain other objects may get a vote if they are in or out, and that's called a witness, and we'll get to that in a second. But as long as you have enough votes, you're up. As long as you have, if you don't have enough votes, you're down. It's really quite that simple. The problem is coming from the world years ago where quorum was just a disk, and that's what a lot of people still to this day think it is, and it's not. Quorum is just a model, and there are different things you can do within it. Basically, in the modern world, we've got this. In the modern world for quorum, I'm showing you this visually. You can do this through PowerShell as well. First of all, Windows has gotten a little friendlier, and it's telling you here, hey, I see, didn't want to do that. I see that in this configuration, I think you should have a disk witness. Sometimes this is right, sometimes this is wrong. So it's gotten better. But the witness basically is an additional voter that, depending on your version of Windows, will be used or not used to help you have enough votes. And the goal of voting is to remain odd. So, for example, if you have a 2-node simple cluster, you want to have 3 votes because 2 is a majority. Now, Windows Server 2012 introduced dynamic quorum, which lets you get to potentially 1 node running. But in 2012 R2, they introduced dynamic witness, which allows Windows to basically roll the witness in and out depending on whether you need it. So, for example, if you've got a 4-node cluster, you would configure a witness, or even if you have a 3-node cluster, you configure a witness. If you remain at 3 nodes, it probably won't use it. But if for whatever reason, say one of those 3 nodes goes offline and you go down to 2 nodes, it may roll that witness in depending on how potentially even other things are configured. But bottom line here is that as long as you stay above the minimum threshold, you're up and running with quorum. Now, where this has gone awry, for example, is patching. I had a customer a couple years back who had an 8-node clustered implementation of SQL Server. This is pre-2012, so it's just FCIs. And they rebooted 4 of the nodes. 4 of the nodes crossed the threshold for what they were looking to do, and it caused all of the FCIs, which they thought would remain up and running, to go down. And so they had an outage because their admins rebooted the wrong number of nodes. That's like, don't be stupid comment there. Now, there's a condition called split brain, which you may have heard at. Simply put, it's man-made. And what split brain is a condition where, let's say you lose your network link between your 2 data centers, and somebody in each data center manually forces the cluster online. At that point, both sides think they're the master of the cluster. That is split brain. There's no way that can happen automatically. That is a human-created condition, not something you really need to worry about, but something that you need to think through and make sure it doesn't happen. Now, in talking about this witness thing, what is a witness? So, it can be a disk, it can be a file share, or in 2016, it can be a cloud witness. Now, where this really helps in terms of cloud witness is, again, this multi-site scenario where, you don't want to configure a 3rd data center to, say, put a file share witness in. That, for a lot of people, is not a reality. Not everybody can use the cloud, so cloud witness might be difficult for some of you. But the nice thing about cloud witness, which unfortunately is Windows Server 2016 and above, is that it's just a blob that, as you can see there, is like 0 bytes. So you can get this done relatively easily with pretty much no cost as long as you have an external connection. Now, the problem is a lot of my customers, we tend to work with larger enterprise customers, and they don't always have internet connections from their nodes. They sometimes, have these behind a firewall and don't allow internet connections. So witness resource and do you or do not configure it, and what are you going to use, disk, file share, or potentially cloud if you're using Windows 2016 or later. It's a conversation I have with my customers, and we usually spend a good couple of hours working through their scenarios. But just know that by default, you shouldn't have a disk, and especially if you're doing an AG with standalone instances, because you can do that. You don't have to cluster the instance of SQL to have an AG, and you have all standalone instances participating. Why would you create a disk-based witness when you have no shared disk? It makes no sense. Here's another one that I've seen quite often over the years. Now, when you're creating a clustered instance of SQL Server, you need some form of shared storage. Traditionally, it's always been disks presented to the cluster nodes, and then you would give them a drive letter, or you could use a mount point, but you still need a drive letter with a mount point. The problem comes in, and this goes back to what I was saying earlier with resources. If you get, let's say, a drive E and they carve up 10 terabytes for you, you come back 2 months later and you say, hey, I'm doing another FCI, I need another disk. And they go, well, I gave you 10 terabytes, just use it. That drive E, and let me show you that here in my 2012 cluster. Go back to full screen. You'll notice here I've got a disk here, okay? SQL disk 1, and you can see my storage pool of disks. It's assigned to this role. And if I look at the dependencies of my somehow that got broken. So this is something that you should never see. I think, there it is. Didn't give enough time. Whew. You'll see that's dependent on this SQL disk resource. Basically what that says is SQL Server cannot come online until this disk is online. And you always want that, even if it's a mount point, because obviously if the disk isn't online, your databases couldn't be online, and that's a very bad thing. But a disk lives in a single role. So if this was that 10 terabytes I was talking about like a minute or two ago, and your storage folks thought that they were done with you, they're not. Again, every single instance will need its own disk resources. So if you don't want to use drive letters and you don't want to use mount points under drive letters, what can you do? Well, starting in SQL Server 2012, you can use Server Message Block 3, or SMB, shares. So basically that's just simply put whack, some type of server name / share name, which is really a folder sitting on that server. But now that means your network needs to have great throughput. Especially if it's going over a shared network. It's not iSCSI. This is using it like basically a file server to serve up your SQL Server databases. You can also do it for standalone as well. It's not just the cluster things, but it removes the dependency on drive letters. Another thing that you can do to potentially free up some of this stuff, TempDB is an expensive resource. So what they've done for clustered instances of SQL is you can create a local TempDB for your clustered instances of SQL. The problem there is if you've got multiple FCIs in a Windows cluster, you've got to have multiple folders since the names of the TempDB files are the same. You couldn't have a master, say D TempDB folder and have all your TempDBs in there. That won't work. There's also clustered shared volume, which I don't have a demo up here to show you, which is basically where all the storage is presented to all the nodes, although it's only used by a single node at any given time. Both with SMB and CSV, now your planning goes to what the folder structure looks like. So you need to, if you haven't updated your skills and you've been implementing FCIs for a while, there are new storage options available to you. Now, if we're talking at the hypervisor layer, for example, if you're doing this in Hyper-V, you could do what's known as shared VHDX, which means you have a single VHDX file used like a shared disk file. In VMware, you might have RDMs or raw device mappings. Maybe you'll be using iSCSI and guest. But you need to understand what your options are to deploy this right. Because you may make assumptions, your storage folks may make assumptions, and it leads to unhappiness. Another big thing in a lot of environments, the question always comes up, so do I need Active Directory for a cluster? In most cases, the answer is still yes. And for a lot of my customers, for example, if their SQL servers are behind a firewall in a specially caged off section, they may just implement a couple of AD servers just for their SQL Server implementations. But having said that, Windows Server 2008 and later, by default, will create objects in Active Directory for the Windows cluster and for everything that gets a network name, meaning your FCIs and the listener. So you need a process for that to work, whether somebody on the back end does this for you before you install your SQL or configure your listener, or you have the account executing all this has the right permissions and it's all set up properly. Because if you don't, what will happen is, for example, if you're installing a clustered instance of SQL, you'll get 3/4 of the way, you get almost to the very end of the installation process, and things will fail. And that's because it couldn't go create things on the back end. And I'll show you what this looks like in a second. The other thing here comes to names and making sure that they're all unique. I'll show you a little bit of that as well, but not as much. Now, in Windows 2012 R2, they did implement for basically AGs where you didn't have to create these objects. This was known as a DNS cluster or DNS-only Windows cluster, but you still needed to have domain accounts. So you still needed Active Directory in some way. They took this a step further in Windows Server 2016, where you can have what we were, for better lack of a term, is a domain-agnostic cluster. So you can, but it's only for availability groups, not for clustered instances of SQL. Simply put, what this is you could have, say, a node, say, in data center A, a node in data center B, and you want to set up an availability group. Basically, you use certificates just like you did with database mirroring, and it all works. You still set up a cluster, and it's a nice thing. Again, I don't have a demo to show you, mainly due to time constraints here. But it's pretty cool. It does just work. I actually have, I think, a blog post on it. Now, the challenge here, though, is if you're using Kerberos, Kerberos isn't supported in that configuration. So, you know, there are trade-offs you're making here. If you want to simplify things a bit, you lose a few things. But in Windows Server 2016, there is the option with AGs to not use Active Directory. So what does some of this look like? So if we're looking at this cluster, okay, so here's my Windows Failover Cluster. Now, here, and this is a concept I want to explain because it's not evident. So you see here name, mini. This is what's known as the network name in the cluster, okay? This is what Windows cares about. This is what gets registered in DNS. So, by the way, there are DNS entries that go along with all this that are associated with the unique IP addresses. So we've already got two unique names, the name of the Windows Failover Cluster, which is Sony, and the name of the network name. Now, in the course of a domain, you can't reuse those names if they have AD objects. And you especially don't want DNS conflicts. So all these names have to be different. Every time you install an FCI, has to have a unique network name. The named portion here, so when I connected earlier to Minidisk, this is purely a SQL Server naming convention, this disk part. That has to be unique within context of a single Windows Failover Cluster. But if I had another Windows Failover Cluster, say named Allan, I could have a separate instance there called Paul/Hirt, or I could have one called Compact/Disk, and it would work there. But bottom line here is you need to keep your names straight. But how does this relate to Active Directory? So let's go look at my AD controllers here. So let me go out here, go to my domain controller, log in. Okay. Let's try and get the screen resolution so it maps to what I'm doing. Perfect. Apply it. Yes, all right, we're full screen now. Excellent. Keep changes. So if I open up Active Directory, you will see in my computers, here's Mini. Oops, I guess I don't have zoom it in here, I'm sorry. Thought I did. I've got Mini, and then I've got Sony. Now, Sony is the Windows Failover Cluster, and if I look at the properties for Mini, you'll see the Sony $ here. Sony $ owns or has permissions on this object, so it's a parent-child relationship. So it's what I was talking about earlier, and I'm going to go back to that slide. So in the example I just showed you, the CNO was Sony, and the VCO was Mini. Okay? Now, if we go back here and look, didn't want to show you that yet. If we go back and then look at DNS, for example, go back to full screen. If I look at my forward lookup zones, here's Mini. Oh, a little further down, and here's Sony. So somebody on the back end needs to account for this stuff. Again, you can't just go implement an FCI or an AG because there's touches on the back end. There are processes that need to be in place for this to work. And if you're going to be doing a lot of this, you need a very repeatable and scalable process. And the last thing I'm going to talk about before I go open up the floor to questions is terminology. Kind of making light of this, but active-passive, and always-on are not the right terms for pretty much anything. I said, improper terminology makes kittens sad. Now, when it comes to Windows and availability groups, a lot of people, for example, on the Windows side still use MSCS. In fact, Microsoft does in the wizard for installing an FCI, and it drives me nuts. They refuse to fix it. I brought it up to them for basically about 10 years now. MSCS was last used in Windows Server 2000 to show you how old this is. The Windows part of a cluster is WSFC. You know, and also one thing that you should never do is never use just the word cluster. I've got a SQL cluster. Well, what does that mean? Do you have FCIs? Do you have AGs? Do you have FCIs and AGs? You know, what the SQL cluster is no longer even remotely specific enough. Now, always on, the big thing is that it's not the availability groups feature. Always on is a marketing term that encompasses both the AG feature and the clustered instance or FCI feature. And so the proper names are always on availability groups and always on failover cluster instance. Fine. Problem is, during its history, before it became a feature, or while it was being birthed as a feature, before they settled on availability groups, AGs had a few names. There was Hadron, there was HADR. It was actually always on for about 5 minutes. And then they finally settled on AGs. Now, you'll see remnants, for example, of HADR. So if you look at the DMVs for availability groups, some will be like sys, DM, HADR, or whatever. And if you didn't know that the feature was called HADR, that wouldn't make sense to you, but that's why it's the way it is. So when you're talking about availability groups, you should always use the word availability groups, and if you're abbreviating it to AGs, it's not AOAG, it's not AAG, it's just AG. It just helps have everybody has a common basis for speaking about these things. Now, the problem recently, and I've got a link to my blog post later, is that Microsoft recently decided to start putting the space back into always and on. So for 2012 and 2014, always on availability groups, always on FCIs have no space. Now it's nebulous because, and again, you'll see in the blog post later that I have a link to, Microsoft has reintroduced this space, and it's very confusing. So active passive and active active are completely wrong for clustered instances of SQL. Just have been for years. And the reason they're sort of they exist in the SQL world is taking you back to the old SQL 7 days, pre-SQL 2000, when at most you could have 2 installations, they weren't even instances, installations of SQL running on at most 2 nodes. So it was either running on one node and not the other, so that was active passive, or you had 2 nodes and one was running on one was running on the other, and that was active active. That made a whole heck of a lot of sense. But now when we can have clusters with up to potentially 64 nodes, and by the way, don't ever implement a 64-node SQL Server cluster, you will tear your hair out. You basically have, if you have a single FCI, it's a single instance failover cluster, and if you have multiple instances, it's a multiple instance failover cluster. Now, let me give you a little bit of ridiculous examples to make the point. So if you've got an 8-node Windows failover cluster with 12 clustered instances of SQL, are you going to do it active, 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 active? No. Because what happens, for example, if nothing is running on one of the nodes, let's say it's only running on 11 nodes, is it active, 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 active? No. Is it active, 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 meaning the number of nodes you have? Well, no. It gets confusing. Sorry, I said 11 nodes. It's 8 nodes. But point being, right, it's not even just active active because you've got 8 nodes. So saying I've got a multiple instance failover cluster with 12 FCIs, boy, that clears it up right away. I know I've got 12 clustered instances of SQL on a Windows failover cluster. Or even just saying I've got 12 FCIs on 8 nodes is so much better than saying I've got an active cluster. When you start talking, it's like, well, I've got 4 nodes and 6 instances. You know, it even hurts in the small scenarios. You know, if you've got 4 nodes and 3 instances, which is what we call an n+1 or an extra failover node, or really what is n plus I, where I is some number of extra nodes. It could be more than one. It's not active, active, active because you're not running anything on the 3rd instance. Sorry, on all 4 nodes. It's not active, 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 passive. Well, it sort of technically is, but what if it was active, active, passive, passive, right? But that doesn't make it the last one, which is active, active. So that's why, again, in this case, you say, hey, I've got 3 FCIs on 4 nodes, or I've got a multiple instance failover cluster with 3 instances. So much better and gets right to the heart of the matter. Okay, so at this point, this is pretty much it. I will stick around for questions if we go over. I'll make sure that the presentation gets uploaded because these links, so you don't have to type all this out. But just a quick rundown. I have an FAQ for AGs. Those are those 2 links that you should really consider for doing virtualization. For proper terminology, I've got some blog posts. So with that, let's open it up for questions. I don't know if Warwick, you want to read them to me, or if we look at the window here.
Yeah. Well, thanks, Alan. Yes, we've got a couple of questions from throughout the session. So the first one, can we configure a hybrid FCI, i.e. one on-premise and the other on cloud, i.e. Azure or AWS?
So Good question. Technically, yes. So the one nice thing about one of the Microsoft things they have done over the years is, what I didn't talk about it here, but there's a process called validation that you have to run at the Windows level that basically checks to make sure your Windows portion is okay. And as long as Windows says you have a valid cluster, it doesn't matter if you have your nodes all on premise. They could be held. They could even be in Azure and AWS and cross them. It doesn't matter. The challenge with FCIs, and not AGs really, is your storage. So what are you going to use for shared storage in that case? You can use a third-party tool, for example, something like Sybase Data Keeper to help you keep things in sync. Your challenge, in the FCI world now becomes, what am I doing for storage? But it is technically possible. As long as you pass validation and Windows thinks it's a cluster and you can present up storage to do FCIs, absolutely. In the AG world, by all means, you can span things if you're doing standalone instances of SQL. Again, you can do cloud to cloud, you can do on-prem to cloud, and that on-prem could be physical or virtual.
Okay. Next question, Alan. Is it compulsory to create dependencies on disks as soon as we add them to SQL Server resource groups?
Good question. So for disks, if they're created as part of install, SQL Server will automatically add the disks as dependencies. I'm going to put a little asterisk there as they've changed behavior a little bit over the years. I believe SQL Server 2012 is the first version that will do mount points. I believe through SQL Server 2008 R2 it would do the named disk, but not the mount point, and you would have to add it. So in that case, yes, you would immediately have to, after you install your FCI, go and do it. But for 2012 and later, I'm 99 and 44 100% positive SQL would do it all for you. Now, if you want to, say, add a brand new disk, like you present it to the Windows cluster, move it to the SQL role, at that point, yes, you will have to manually add the dependency. But if you do it all at setup time and it's a later version of SQL, you should be all set.
Okay, so we've got another question here. Is there anything that would, oh, no, hang on, we've changed. If I have an application that is not configured to identify read-only and read-write connections, is there any specific steps I need to carry out in setting up the AG listener?
So it's not really the listener, actually, where that gets configured. So when we're talking about read-only, there is a concept called read-only routing. So for things to work for read-only secondary, there are basically two ways you can do it. All right, well, two ways. You can use a listener, or you can go direct to that read-only node. And that depends on how you set up your AG. Plus, with read-only routing, you're basically defining what could be a readable secondary, like if it's a secondary, how that gets all routed. So as long as you set up your read-only routing correctly, and you're using a listener, you basically, in your connection string, just tell it it is a read-only connection string, and it should go to the readable secondary. I don't have a demo live right now. It's powered down. Otherwise, I'd show that behavior to you. But I can tell you it does work. Now, if you can't modify your connection strings to basically direct it and tell the listener that you need to go to the read-only, there's nothing you do at the listener level. Even if you configured everything right for read-only routing, if you're not, the secret sauce really, besides getting it right in the AG configuration, is making sure you're telling the connection string to use a read-only. So you may have to have two different connection strings for the same app, and then depending on what the app is doing, call different connection strings. So if the app can't do that, chances are you're not going to be able to take full advantage of readable secondaries. If that didn't answer your question, just let me know.
So just to add to what Alan was saying there, with the connection string, the additional component you put in there, you tell it that to go application intent equals read-only, for example, and that will then allow it to access the read-only routing tables that Alan mentioned for it to go from the primary replica to the secondary replica. So our next question, Alan, is there anything that would automatically change the vote weight of a cluster member, or are these set and forget?
Oh, that's a loaded question. So I didn't explain this totally, but let me show you. Let me go back to my demo here for 2012 because it's easier seen here. So if I do configure cluster quorum settings, come on, advanced quorum and witness selection. So 2012 and later, I can alter my voting scenario. Okay. Now, by default, everything gets a vote. All your nodes get a vote, and if you have a witness, it'll get a vote in 2012. Now, with dynamic quorum, if, let's say, the Walkman node went down, it may still be assigned a vote, but it may not have an active vote. So dynamic quorum will alter the total number of votes dynamically based on who's up and who's down, and you yourself can say deselect that. Okay. So for example, if you have a secondary that's totally only for read-only, you're never going to fail over to it, you can remove a vote. So at that point, it wouldn't count towards quorum, the total number of quorum votes. I generally don't recommend that because I would say never. Now in 2012 R2 with dynamic witness, it'll roll the witness in and out. So in 2012, you still have to manage witness. In 2012 R2, so is it set and forget? The only version that's pretty much close to set and forget is 2012 R2. If you're still doing 2008 R2, all of this is manual. Voting was KB hotfix, and there's no dynamic management of it. So, for example, if you went down from 3 nodes to 2, you would have to add in your own witness resource. So, a lot of this is going to depend on your version of Windows that you've implemented your AG or FCI on, and I completely 100% recommend doing at this point, if you can, Windows 2012 R2, or if you're even looking at it, especially when it comes out, Windows Server 2016, because it's dynamic quorum and dynamic witness. So I know it's kind of a long-winded answer, and it's not really straightforward. There's more to it even than that, but that's really the quick view of the world. But I don't think there will ever be 100% set and forget, but Windows Server 2012 R2 and 2016 get pretty darn close.
Okay. So, Alan, what is the general best suggestion for doing a physical cluster in one location with a physical DR at a remote location? We're currently doing a FCI locally with a remote mirror.
Okay. So basically, could you just repeat the first part of that again? It got a little garbled on my end because of, lovely internet.
Okay, so what is the general best suggestion for doing a physical cluster in one location with a physical DR at a remote location?
So what you've done there with the mirroring, and again, this is kind of like a lot of things, and you may hate me for this answer, but it's going to be, it depends. There's no one best practice. There's so many factors. We're working with a customer now, for example, where they wanted sort of a canned solution, And a lot of it depends on your requirements, your SLAs, what else, because it's not just, because if you think about the act of DR, when your company makes the decision to go from data center A to data center B, that's not a simple flip of the switch. That's never automatic. And even for SQL Server to come up in some cases, there's a bunch of other stuff that needs to be done first. So SQL Server isn't necessarily at the top of the food chain. So we're talking potentially hours of work to get to the point where you can even start looking or doing anything with SQL Server. So having said that, right, so that goes back to basic requirements. Now we start looking at things like what's your network pipe between the two? What's your transactional throughput? What else is sharing that pipe that's going across? Are all your VMs being replicated if it's VMs? If it's physical, what's your transaction rate? All these things start to factor in. Your physical infrastructure matters here. So then it goes down to another level of management. So if you're already doing FCIs, you're familiar with clustering. If you're using database mirroring, FCIs and database mirroring was never a natural fit for synchronous. For asynchronous, it was fine. If you're already doing database mirroring, you could convert that to an AG. But it really depends on tolerance. But the thing is, if your recovery SLA is 12 hours, doing even database mirroring or or AGs could be overkill. If your recovery time is 12 to 24 hours, something as simple as log shipping could work. So for me, it all starts with when it comes to DR solutions, of looking at your requirements, and then picking the right technical solution to fit the needs. Now, the problem is sometimes the right technical solution, as I said, doesn't fit the infrastructure. So then that begs the question, can you do something with the infrastructure? And if you can't, then it goes back to the drawing board of where your trade-off is going to start to come in. So again, I know it depends is a horrible answer, and I didn't give you anything super specific of this is the best thing to do, but it is so situation dependent. One nice thing about AGs is that it is one single feature that can span multiple data centers. So on that tip, AGs are a wonderful feature. But because it's Enterprise Edition, not everybody can do it. So if you're doing, for example, Standard Edition of SQL Server right now, and that's how your FCIs are done, and you're using database mirroring, and that can be done in Standard as well, guess what? If you're not willing to pay the cost of Enterprise Edition, it rules out AGs completely. So you have to look at all those factors to come up with the right solution. So I hope that helps you.
Thanks, Alan. So our next question is, given we have a requirement for multiple instances with multiple AGs and a number of nodes, what do you consider when deciding between setting up one cluster with all nodes and many instances, or splitting up the nodes into multiple clusters with fewer instances per cluster?
So let me take a step back and ask the person who put that in if they could type in another answer or question of, are we talking clustered instances of SQL or standalone instances of SQL? Because the answer kind of makes a difference. So if the person can clarify that question, I promise we'll get to that question. I just want to make sure I answer it correctly.
Standalone instances, Alan.
Okay. So for standalone instances, since the instances are unclustered, you don't have to worry about that. The reason why I asked that was there is a condition I like to call, in Ghostbusters vernacular, for those of you familiar with the old movie, which has now been remade and coming out, I think, this year, where crosses streams. So if you have, for example, two FCIs in a single Windows cluster, and you want them to participate in an AG, they could never live on the same node. AG won't allow you to be configured. So, in the standalone scenario, it's the best scenario because the number of instances essentially don't matter. Although you can't really do, or you really shouldn't do, an AG between two instances on the same node. That's generally a bad idea, and generally won't work. So you need to think about, at some point, how many nodes you want to manage, because if it's all standalone servers, you're not managing SQL in context of the cluster. It's just the AG that's part of it. So, at that point, it then becomes the number of replicas. So in SQL 2012, we had a total of 5 replicas, 1 primary up to 4 secondary, and in 2014 and later, it's 9. So 1 primary, 8 secondary. So at most, assuming, let's say your worst case scenario, 9 instances on 9 separate physical or virtual boxes, or even VMs in the cloud, AWS or Amazon, you're looking at most 9 nodes with your standalone instances, and then everything on top of that. When SQL expands out beyond that, sure, you could potentially have more than 9 nodes. Now, you could have potentially, let's say, a 25-node cluster where you've got 25 instances and that are all standalone and various combination of AGs. That's going to be a lot to manage. But if you're doing it the way most people implement AGs is you have, say, an instance or another instance on a node, both of those not participating in the same AG, and a limited number of nodes. So you're looking at most maybe 8, 9, at worst case 10 nodes, and then your AGs on top of that. Now, what you need to then consider is your maintenance. So, reboots. Make sure that you have the right number of nodes, that your admins may not take you completely down, and that you're involved in making sure that doesn't happen. So I hope that answers your question, but generally, what I see out there is people implement, in the standalone case there, the number of nodes is the number of standalone instances they have. You throw FCIs in the mix, that may go up a little bit, but I generally, in the FCI world, anything 8 gets to be a little crazy from a patching standpoint. Even a little less than that is a little crazy, but it is what it is. AGs less so because you're not clustering the instances, but you still need to think of maintenance. So again, depending on FCI or AG, slightly different scenario, but you're not going to have generally a 25-node cluster in either scenario.
Okay. So, Alan, this one's pretty much for you in your consulting side of things. Have you ever come across the issue with MSDTC/cross-database transactions causing AG databases to not come back online and not be recoverable? Any comments on this? I've read the post, but never seen it or been able to reproduce it to experiment with it.
So this is one of those things where if it's working, and it could work, right? Microsoft basically has no guarantees. So what the question basically is for those of you that don't know, a distributed transaction, basically you enlist a transaction in your application in database A. It's got to complete in database B, which may either be on the same instance or another instance somewhere else, before everything can be done in database A and roll on, right? Now, AGs can handle multiple databases, but it's not DTC aware. Just like, by the way, I want to be very clear about this: database mirroring, replication, and log shipping. So it works the same as everything else pretty much that came before. People were disappointed by that because you could have multiple databases in an AG, but that's a separate issue, right? Disappointment versus it's no different than anything else, two different things. So when everything is up and running and your AG is being synced, you should probably never see any problems. The potential, but not guarantee of a problem is, let's say you were in the middle of a transaction, a distributed transaction, something failed on your primary, you have to bring the secondary replica online. there's no guarantee that that transaction was either fully committed or rolled back. And like the person who posed the question said, it's very hard to necessarily reproduce or see because you have to hit the right magic conditions. Because if it completed on time, you'll never see the problem. Microsoft announced partial DTC support in 2016, but it's not full. So for most people, it's still like the way it was in 2014 and 2012 at the moment. They're saying that the amount of work to get it fully done is going to be quite a little bit, so if there's a potential it may not make it into RTM. I'm hoping they finish it either for RTM, fingers crossed, or after. So the only thing I'll tell you is, for the person who asked the question, you're right. You roll the dice. Just knowing that AGs don't work with DTC has caused some of my customers not to implement AGs, even though they've done database mirroring and not cared, which is kind of ironic. So you kind of have to weigh your risk, and then, because if you're, for example, if your transactional rate is not that high, or for the most part you're going to be controlling the failover, like in planned downtime, it's not going to matter. It's the unplanned downtime that matters. So that's the best answer I can give you. It's hard to track. Like the person asked the question, it's not always going to show up. But when it shows up, it's going to be ugly, and you have to find a way to back out and fix that. SQL's not going to fix that for you, and that's the risk. So if your company really doesn't like that or is not willing to invest the time in making that work or having the procedure for figuring out what that delta data or that didn't get applied, don't do AGs or database mirroring or log shipping or replication. It's really that simple. The only feature in SQL Server that accounts for DTC are FCIs, which are their own headaches around DTC and its configuration, which I didn't really touch in this talk. But so honestly, it depends. Now, I'm hopeful that in 2016, Microsoft finishes the job with implementing DTC for AG so we can have a fully supported solution. But as of now, you're just going to have to assess your risk and hope you don't run into any trouble.
Okay. Now, this next question, Alan, goes back to one earlier where we were asked about the setting up a physical cluster in our local and then using mirroring across to a DR site was, yep. Thank you. Is a local synchronous and remote asynchronous setup a generally accepted mode?
Yes. That's something that a lot of people will do because, again, AGs are a nice feature that you can do local high availability with synchronous. Doesn't need to be automatic. You can just have synchronous manual failover. You don't need to have it be automatic failover. And then you can have your other replica be asynchronous. So yeah, that you can absolutely do that with AGs. And again, if you're already doing database mirroring, if you've got 2012 or 2014, it's really just as simple as unconfiguring database mirroring, configuring the AG, and then adding that third node into the cluster, and adding it in as a replica. It's not a bad process.
Okay, so it looks like our final question for today is, so it's a troubleshooting question around FCIs. Somehow the network name being deleted and now the FCI is not starting. How do we troubleshoot this, and how can we bring it online?
Well, I guess the question there is if it was. It really depends if it was deleted from the Windows cluster or if it was deleted from Active Directory. If it was deleted from Active Directory, so to the person who asked the question, where was it deleted? Because sort of the answer is it depends, and I'd like to know where it's deleted from.
Okay, so hopefully they'll give us an answer very shortly.
So we have a moment here. First of all, let me say, as we're finishing up, and if you have another question, again, I'm more than happy to stick around for a couple minutes here. But thank you all for attending. I know it's your lunchtime, and also another sort of quick plug of I'll be down there next month, so we'll make this available in a couple days' time, and you can see the link to the training. So if you're interested in hearing more about this stuff and getting some hands-on experience and being able to pester me in person, by all means, sign up for the training in Melbourne or Canberra.
Okay, so it was deleted in Active Directory.
Okay, so if it's an old version of Active Directory, I might be just saying my condolences. If it's a newer version of Active Directory and they have enabled the recycle bin, it's as simple as getting it out of the recycle bin. If they have not enabled the recycle bin, it may not be recoverable, and you can Google or Bing out, whatever your preferred search engine is, on how to deal with that situation. But it's not necessarily easy, and it's kind of ugly. And your worst case scenario, if it's really borked up, is a reinstall of the instance, or repair potentially. But again, there's information out there on handle those scenarios. Having said that, by far the easiest thing, and this may be a lesson learned for the person's company that he or she works at, is that the recycle bin should always be enabled in Active Directory. Actually, I think I have enabled. Let me show you real quick. So let me go to my domain controller. It's FCI. So give me 1 second here. You go back to full screen. So go to my local server, ADDNS, Directory Administration Center. Let me move this over. So I've already enabled it. But so you see there's SQLHA local. It's grayed out here. I can't zoom in because, again, I didn't do it. But there's this enable recycle bin. Mine's grayed out because I already have it. And if I have a deleted object, you'll see it's in here. I can quite simply restore it and move it where it needs to go. So that is your best case scenario. 2008 R2, you could use like ADSI edit. Again, all this stuff's documented out there. But if none of this was enabled, it's a little more difficult. Consider this a lesson learned. Let me actually show you one more thing while I'm in here in Active Directory. So to prevent stupid from happening, because I guarantee you the person who's probably asking this is DBA, there's a property on the Active Directory object. Attribute, where is it? No. General. Been a long day. General, where are you? Operating system. It's prevent object from being deleted. Oh, there's object. Duh. So there's this. Okay. Make sure that this is set. So again, I can't really. Let me see if I can zoom in at this level. No, I can't. There's this protect object from accidental deletion. So if that's set, for example, now if I have domain admin privileges, which I do here, I'll say, do I want to delete this, yes or no? It basically pops up saying, hey, I don't have privileges. Now, I do have privileges. It's just basically a warning that in that case. Now, obviously, if I then went and unchecked this because I had permissions to do it and deleted it, that would be an issue. So to prevent stupid, I highly also recommend, on top of enabling the recycling bin, also making sure that all your VCOs and CNOs, so your network name objects, have protect object from accidental deletion enabled. That will hopefully prevent what this scenario that you're in right now. The person who asked the question, and I'm sorry you're in that situation. I hope my answer helped you.
The only last thing that they did come back with, Alan, was any way I can start the instance without the network name?
No. Clusters are all dependent on that stuff. Because, and the reason for that actually, and let me show you, it goes back to dependencies. So if I go to my 2-node FCI, I go back to Failover Cluster Manager, you might have seen it when I popped it up, but if I look at SQL Server's dependencies, it is dependent on the network name. So there's no way. Now you could try and delete this and bring it up. I strongly, and that consider that 128 point bold, don't recommend doing that.
Okay. Oh, we've had one late one.
Sure.
We have an AG Group 1 set up on Node 1 and Node 2. What are the best practices to move or migrate AG Group 1 to better server nodes with latest hardware with better configurations? Do we have to set up everything from scratch?
Another it depends question. Short answer is yes. Now, having said that, if it's the same major version of Windows, Windows doesn't care about differences, say, in processor and memory and stuff like that. So if it's the same major version, could even be different service pack level, you get a warning if you're on validation, but who cares? You could put them in the same cluster, Windows cluster that is. You know, obviously bring them in as replicas, and then you could basically remove the original nodes as replicas. So you don't necessarily need to create a whole new cluster. If you're talking different versions of Windows, and it's lower than Windows 2016, the answer is absolutely new cluster, new configuration, which may cause issues with names because you can't have two of the same name in domain. Now, if your nodes are currently Windows 2012 R2 and you're looking to go to 2016, that will be possible to have for a short time a state where you could have some 2016 nodes participating in a 2012 in what is essentially a 2012 R2 cluster, so you can upgrade everything, and then basically you can phase out and remove or upgrade the 2012 R2 stuff. So those are your scenarios. So if it's same major version of Windows, you could, because Windows allows for differences in potential patch levels and hardware configuration, absolutely just roll it into the same cluster, bring them in as replicas, and just phase out the original ones. You could build a completely new Windows cluster with a new AG and just take a backup from your primary and move it over and then seed everything. Or again, 2012, 2016, similar to the rolling into the same cluster. So you've got options. It depends where you're at and what you want to do.
All right. So with that, I'd like to say thanks to everybody for attending, and I'd like to say a big thank you for Alan for his time joining us today and talking to us about the top 10 do's and don'ts to do with clustering. So thank you very much, and I look forward to seeing you all same time next month. Thank you.
Thanks, everyone.